Okay. So the solution for x is greater than 3. So this is all numbers whose distance from 0 is greater than 3. Well, here's 0. Here's 3. It's all the numbers greater than 3. Same with this direction. Here's -3. It's all the numbers out that way. All of those numbers, when you take their absolute value, you'll get something greater than 3. Okay. So this is a typical graph for an OR. So the first one is the simple one where you just take away the bars. X is greater than 3.5. Then you have your OR, and then you have your next one. X is less than, switch the sign, and make that the opposite. Same procedure as with and, but we can't then combine it into a nice neat little sentence. Okay? X is greater than or equal to 2/5, or what would be the next part? Yeah.
X is less than or equal to -2/5.
-2. That's perfect. So, same old deal. We're going to take away the absolute value signs. There's our first one. Or x minus 7 is less than or equal to -4. So you flip the sign and you change that to the opposite. Okay, now I'm going to add 7 to both sides. X is greater than or equal to 11. Or we're adding 7 to both sides. X is less than or equal to 3. Okay, anybody have an answer? Yeah, what you got, Rosanna?
I have x is less than 2 and x is less than -6.
Wait a second, you've got
X is
one
greater
of
than 2.
Thank you. Yes. So you have x plus 2 is greater than 4, or, remember that's an or, x plus 2 is less than -4. So we're going to subtract 2 from both sides on both of them. One, it's going to be 3x plus 1 is greater than or equal to 5, or, right? 3x plus 1 is less than or equal to -5. Okay, so this is 3x greater than or equal to 4. This is x is greater than or equal to 4 over 3. Or 3x is less than or equal to -6. So x is less than or equal to -2. So down here on our graph, this is all less than or equal to or greater than or equal to, so we've got solid dots. So here, greater than or equal to 4/3 would be at 1 1/3. Okay, solid dot. And then it's greater than or equal to, so it goes to the right. Less than or equal to -2, you have a solid dot at -2 and an arrow to the left. What'd you get?
X is less than 4 or x is greater than 3?
It's and, because it's less than.
Oh.
I tricked you guys. So it's 2x minus 7 is less than 1 and greater than -1.
So wouldn't 20 be an and also?
Yeah.
Oh yeah.
Yeah.
Did you say or?
Yeah, my bad.
I didn't catch it. Okay, so we're going to add 7 to both sides. So we get 6 is less than 2x is less than 8, and we're going to divide by 2. 3 is less than x is less than 4. Okay? This one's an and also, so that means 4x minus 5 is less than or equal to 3, greater than or equal to -3. We're going to add 5 to both sides. 2 is less than or equal to 4x is less than or equal to 8. Divide by 4, you get 1/2, right? 2 divided by 4 is less than or equal to x, less than or equal to 2. And if you graph it, this one's going to have 2 open circles and a little tiny graph. This one's going to have a closed circle at 1/2, a closed circle at 2, and a line in between. Yes?
So is the difference between or and is and you can put it in a full line, but or you only...
Yes, exactly. You can make one sentence out of the and. You don't have to. You'll still get the right graph. Yeah.
All the ors, are they always out this way, or?
Almost always, once in a while, they'll give you one where it's overlapping, and
Oh.
so, you know, so you can't count on it, but that's the typical graph.
Okay.
Yeah. number line, here's 0, here's A, and here's B. The distance between A and B is the absolute value of A minus B, or the absolute value of B minus A. Find the distance between -9 and 3. So we're going to subtract one value from the other. It doesn't matter which. Okay? So this would be the absolute value of -9 minus 3. That's -12. So the absolute value is 12. Okay? What if I did the absolute value of 3 minus -9? That's 3 plus 9. That's 12. Okay, so it doesn't matter which is first, but that gives you the distance on the number line. So we're going to apply that to this. Translate this statement into an open sentence. Open just means it has a variable in it, using absolute value. The numbers, so that tells me x, whose distance from -5.5. Well, the distance is the absolute value of the number minus the other number. So minus -5.5, right? I'm just applying my distance formula. Okay? Is at most. What's my sign there? What's my at most? Less than or equal to 6. Okay, and then I can solve that. So that's x plus 5.5 is less than or equal to 6. And then you could simplify that just as we have the others.